All right, we're going to continue in chapter 9 with dividing radicals now. In other words, we're going to be dividing square roots. All right, so how do we divide square roots? Simplify. What we simply do is we simplify the radicands from the numerator and denominator as much as we can. If there is a radical left in the denominator, though, you will need to rationalize the denominator. To rationalize, what you simply do is you multiply, okay, both the numerator and denominator by the radical that is left in the denominator. Now, what that will do is that will make a perfect square in the denominator. Then, once you do that, you will simplify the radicals and you will also simplify the fraction if possible. Okay? So, let's give this a shot. So, the first thing we're going to do is we're going to simplify. So I look here on this first one and I see, oh, square root of 16, that's a perfect square. So that would make a 4 come out. So square root of 16 is 4. Also, I noticed the square root of 36, that is 6. So that would get me 4 over 6. And then I can look at that and say, oh, a 2 goes into both of those. So I divide them both by 2, and I would be left with 2/3. Okay? Here on this second one, I start off and I notice, oh, the 18's not in a radical, so I'm just going to leave it alone. The square root of 4, the square root of 4 is 2, so that brings over. Then I look at that and I say, oh, 2 goes into 2 once, 2 goes into 18 9 times, so I can simplify my fraction to just 9. Okay? Let's start here on number 3. So the first thing I notice here is it's all under one radical. So the first thing I'm going to do is I'm going to split it apart. So square root of 7 over the square root of 16. Now, square root of 7 cannot be simplified, so I'm going to leave that. But the square root of 16 is 4, so I'm going to bring that down. But there's nothing else I can simplify because the 7's on the inside, the 4 is on the outside. Remember, if you're trying to simplify, only radicands can simplify radicands, and only coefficients can simplify coefficients. Or, if you want to think of it, inside can only simplify with inside, outside can only simplify with outside. All right, let's try these next ones then. If I look here at number 4, I notice I have 5 square root of 2 over the square root of 7. So the first thing I look at here is I say, can I simplify any of this? And the answer is no. So what I notice is I have this square root of 7 still in the denominator. So what I'm going to do is I'm going to rationalize. So what I do is I multiply the top and the bottom, the numerator and the denominator, by the square root of 7. So that's going to give me 5. 2 times 7, because they're both on the inside, would be square root of 14. 7 times 7, they're both on the inside, would be 49. My next step now is I'm going to try to simplify those. 14 does not have any perfect square factors. 49 does. The square root of 49 is a perfect square, so that's going to bring a 7 out. The last thing I check is I look at the 5 and the 7. I don't look the 14 because the 14's inside. It's the radicand. So now the 5 and the 7 are both on the outside. So I look at those and I say, can I simplify anything between the 5 and the 7? And that would be no. So that would be my final simplified answer. Okay, let's take a look at number 5 here. So on number 5, I start off and I say, okay, can I simplify the 3 or the 6? Now on this problem, I'm actually going to show you 2 methods to do this problem. The first one is, let's just stay with what we've been doing. So I've got this square root of 6 still, so I'm going to rationalize. So I'm going to multiply the numerator and denominator by the square root of 6. So that would get me 8 square root of 18 over the square root of 36. My next step then would be to simplify those. So 18 could go into a 9 and a 2. The square root of 9 is going to bring out a 3. So that's going to leave me with 24 square root of 2 over, and then the square root of 36, that's a perfect square. So that's going to bring us 6 out. And then the last thing we can do is we can say, oh, 6 goes into 6 once, 6 goes into 24 4 times because they're both on the outside. So that would leave me 4 square root of 2. Okay, that's one way of doing that process. Now, I want to show you a different way of doing the same thing. If you notice here, you have a 3 and a 6 both in the radicand. And 3 and 6 can simplify. So this 3 and the 6, 3 goes into 3 one time, 3 goes into 6 twice. So what I could do is rewrite this to say 8 over, sorry, the color changed on me, 8 over the square root of 2. Then what I can do is now I can rationalize square root of 2 over square root of 2. Now when I multiply those together, I would end up with 8 square root of 2 over the square root of 4, which when I simplify that, square root of 4 turns into a 2. So now I'm at 8. Now I'm at 8 square root of 2 over a 2. Well, that can simplify. The 2 goes into 8 4 times. And you'll notice my final answer is 4 square root of 2. Now, I don't care which method you do. Both of them are mathematically correct. Some paths just seem easier than others. So if you look at something and you notice something that can simplify, sometimes that will just make your math easier if you simplify early. Okay? So, for example, on this one, if I wanted to, I would multiply by the square root of 10 over the square root of 10. And that's going to get me the square root of 150 over the square root of 100. Okay, so then I can break that down and I can say, okay, the square root of 150 breaks down into 25 times 6, and the square root of 100 is just 10 on the outside. So then we can take that and say the square root of 25 is a 5, so we have 5 square root of 6 over 10. And at that point, I can simplify the 5 and the 10. 5 goes into both of those. And we would be left with square root of 6 over 2. And that would be my answer. If I were to do it the other way, so let me just show that as well. I have the square root of 15 over the square root of 10. Well, one thing I know right away is 5 goes into 10 twice, 5 goes into 15 3 times. Since they're both in the radicand, I can simplify those right away. So now what we have is we now have the square root of 3 over the square root of 2. Now I can rationalize and multiply both by the square root of 2, which is going to give me the square root of 6 over the square root of 4. And the square root of 4 simplifies because it's a perfect square, right? So I can simplify the square root of 4. That's going to bring a 2 out. So what I have now is I have the square root of 6 over 2. The 2's on the outside, the 6 is on the inside. It cannot simplify any further. And that would be my final answer. So understand there are a couple different ways of doing that process. And I do not have a problem either way as long as you're mathematically correct there. Okay? And that is how we divide fractions or radicals and how we simplify radicals in a division problem, and also how we do what is called rationalizing the denominator.